So in this lesson, I'm going to be reviewing oxidation and reduction, and then also teaching you how to balance redox equations. So the first thing is I need to review the oxidation states and just oxidation-reduction reactions in general. And so here are your rules. Just as a reminder, we looked at this earlier this year. Elements, when we're assigning oxidation numbers, elements are always going to have an oxidation number of 0. The sum of the oxidation numbers in a compound is going to be equal to 0. And the sum of the oxidation numbers for a polyatomic ion is going to be equal to the charge of that polyatomic ion. Now, oxygen normally has an oxidation state or an oxidation number of -2. However, when it's peroxide, it has an oxidation number of -1. Hydrogen normally has an oxidation number of +1. However, when it's a metal hydride, so hydrogen is acting with a negative charge, then its oxidation number is going to be -1. Fluorine is always -1 for its oxidation number. And then for group 1 metals, they will always have a +1 oxidation number, and group 2 will always have +2. And remember, the positive charge generally comes before the negative. Now, the reason why we're bringing this up, we're now going to be looking and reviewing oxidation and reduction reactions and realizing that within one reaction that is a redox reaction, you're going to have something that's being oxidized and something that is being reduced. So if you look here, for example, remember oil rig, oxidation is loss of electrons, reduction is gain of electrons. So zinc in this case is going to be oxidized because, as you notice, its oxidation number goes from 0, because it's an element, to +2. And in order to go from 0 to +2, that means it had to lose 2 electrons. Same thing for hydrogen. Hydrogen went from +1 to 0. However, hydrogen, instead of being oxidized, it's going to be reduced, because when you're going from +1 to 0, that means you gained an electron, which means that hydrogen is being reduced. So when we're talking about balancing redox equations, instead of simply making sure that you have the same number of atoms on both sides, the other thing that you need to be careful about when we're talking about redox equations is making sure that the gain and the loss of electrons that occurs, because we're going to be gaining electrons or losing electrons in these types of reactions, you need to make sure that those are balanced as well. And so what we're going to do is we're going to write half reactions. Now, for a half reactions, electrons are going to be placed on the reactant side for a reduction reaction, because reduction is gain, so you're going to gain electrons, so those would be put on the reactant side. And then for an oxidation reaction, it's going to be on the product side. So if you notice here, for number 3, I start with iron with a +3 charge, and I finish with iron with a +2 charge. Well, in order to balance that, I can't gain 1 electron without actually showing that, and so I'm going to put an electron on my reactant side, because if you notice now, -1, which is the charge of 1 electron, +3 gives me +2. So this is going to be quite a bit more in detail in just 1 second as we actually balance full reactions. So what we're going to have to do to balance an equation, so this is a very, very basic one where we haven't gotten into anything other than simply what's being reduced and what's being oxidized. So as you notice, zinc goes from a 0 oxidation number to a +2 oxidation number, which means that it is being oxidized, while copper is going from a +1 oxidation number to a 0 oxidation number, which means it is being reduced because it is gaining an electron. So what I'm showing you here is zinc being oxidized because it's gaining electrons, and so in order to balance this, I need to show the 2 electrons that it's losing to become zinc with a +2 charge, and therefore I'm going to put the 2 electrons on the product side because it's being oxidized. Copper is being reduced, and therefore I have to put an electron on the reactant side. However, notice, in order to balance this, my gain and my loss of electrons, gaining being for the reduction and loss being from the oxidation reaction, those have to be balanced. So I'm going to multiply my reduction half reaction by 2. So I'm going to put a 2, a 2, and a 2 there. And now I can add those together because my number of electrons will cancel. And what I end up with is this. That is my balanced redox reaction. So that is a very basic example. So here are my steps for balancing more complicated half reactions that don't simply show what's being reduced and what's being oxidized. So here's what you need to do. You're going to start off by writing the unbalanced equation. So you're going to identify the oxidation states, and then you're going to actually write the 2 unbalanced half reactions, one for oxidation and one for reduction. Then you're going to balance all of your elements except for hydrogen and oxygen. Then what you're going to do is you're going to balance the oxygens by adding water, and you'll see what this looks like. And then after adding water, you're going to balance using H+ to balance your hydrogens. Finally, you're going to balance the charge on each side by adding electrons. You're going to make sure that the number of electrons that are gained equals the number of electrons that are lost, and then you're going to add the two half reactions. So I'm going to have you keep these steps in front of you as I explain this problem. So I'm giving you this reaction right here. Notice you don't just have copper and nitrogen or copper and oxygen that are being reduced and oxidized. And so what I'm going to do is first identify what's being oxidized and what's being reduced. Well, I know that copper is being oxidized because it goes from a 0 oxidation number to a +2 oxidation number. And so I'm going to write it like that. And therefore, my nitrate becoming nitrogen dioxide, that is going to be reduced. So I'm first going to work with copper and my copper 2 ion. So the first thing that I need to do, well, my coppers are balanced, my hydrogen is balanced, my oxygen is balanced. The only thing that isn't balanced is the fact that I have a 2+ charge on my product side and no charge on my reactant side, which means I need to add 2 electrons to my product side. And so I'm going to do that right there. Now, I'm done with copper. What I need to do now is I need to figure out nitrate. Notice I've got, my nitrogens are balanced, so I balance everything other than oxygen and hydrogen. Now my problem is the fact that I have 3 oxygens on my reactant side and only 2 on my product side. So what I'm going to do, I've got to add water to my product side. I'm going to add just 1 water because then that will give me 3 oxygens on both sides. Now notice I've messed up my number of hydrogens now by adding water. And so what I'm going to do is I'm going to make that equal. So what I have to do is add 2 hydrogen ions to my reactant side to make sure that I have equal numbers of hydrogens on both sides. The last thing I have to do is figure out charge, just like what I did before, up above. So if you look, I've got 2 pluses and a minus, which gives me just 1 overall +1 charge. Notice on my product side, however, I don't have any charges. So that means I have 1 extra plus charge on my reactant side, so I'm going to add to my reactant side also 1 electron. Now the very last thing I need to do is I need to cancel out my electrons, because remember, in an oxidation-reduction reaction, you have to have the same number of gain and same number of loss. Well, right now I've only gained 1, but I've lost 2 electrons, so I've got to make those equal. So I'm going to take my reaction on bottom and multiply the entire thing by 2. So it becomes 2 electrons plus 4 hydrogen ions plus 2 nitrates gives you 2 nitrogen dioxides plus 2 waters. Now, and only now, can I add those 2 reactions together. And so what I end up with, since my 2 electrons cancel, I end up with copper plus 4 hydrogens plus 2 nitrates, and that gives me 2 NO2s plus copper with a 2+ charge plus 2 waters. And that's it. I've now balanced my redox reaction, and it's as simple as that. So look through those steps. Make sure that you feel comfortable completing a problem with the steps in front of you, remembering that you balance first oxygens, then hydrogens, and then your electrons, and then start working on problems in which you're not using those steps because you're not going to have those on a quiz, test, or on the AP. So pause this video and do the practice I gave you. The last type of redox balancing that I'm going to have you do is if I actually have you put it into a basic solution. Now this is going to be identical to the problems you just worked on for balancing redox reactions, except for the fact that instead of just leaving the hydrogens like what you did before, what you're going to do is you're going to add hydroxide to both sides. Okay? And if you add hydroxide to a side that has H+ on it, hydrogen ions, then that's just going to make water. And then you're going to cancel out all appropriate species. So I'm going to show you an example here. What you're going to do is you're going to take NO2 minus, and you're going to separate it out with NH3 with ammonia, and then you're also going to separate out aluminum with aluminum hydroxide. And so what I'm going to do first is notice that I've got to balance my O's, then my H's. And so what I'm going to do is I'm going to add 2 waters to my product side to get 2 oxygens. Now notice I have 7 hydrogens on my product side, which means I'm going to add 7 hydrogen ions to my reactant side. And so the only new thing that I have to do now is simply add 7 hydroxides to my reactant side and 7 hydroxides to my product sides, because this is a basic solution. The last thing that you have to do is you have to figure out your electrons. So here, 7 hydroxides and 7 hydrogen ions, that will give you 7 waters. So that has no charge. You simply have a -1 for NO2, and then you have a -7 charge on your product side, which means I'm going to have to add 6 electrons. So what I'm going to do is, what I showed was that you have 7 waters that are created from 7 OHs and 7 hydrogen ions. Okay, now I'm going to do the same thing, but now for aluminum. And so I'm going to add 4 waters because I need to have 4 oxygens. So that gives 8 hydrogens on my reactant side and 4 hydrogens on my product side. So I'm going to add 4 hydrogen ions, which means I need to add 4 hydroxides to both sides. And so the last thing I need to do is I need to figure out charge. Well, I have 4 negatives on my reactant side, and I have a minus, and then notice that the hydrogen ions and the hydroxides cancel out, and so I need to add 3 electrons to my product side. Now, in order to have those electrons cancel out, because you have to be able to cancel those electrons out, so electrons gained equals electrons lost, I'm going to multiply the entire thing by 2. So it becomes 8 OHs and 8 waters and 2 aluminums and 2 aluminum hydroxides and 8 waters and then 6 electrons. And so what I can now do is add those 2 reactions together, those half reactions together, and I get my final reaction. Now notice I have NO2 minus, you just have to be careful. I end up with just 5 waters, and then I have 2 aluminums, 1 hydroxide, 2 aluminum hydroxides, and then 1 ammonia. And that's how you balance a redox reaction in a basic solution. So the only new thing that you're doing is adding hydroxides to both sides in order to cancel out your hydrogen ions.